Okay, this is Algebra 2, section 5-6, solving radical equations and inequalities. We're on page 352. We first need to define what a radical equation is. Radical equation is a type of equation in which the variable is underneath the radical sign. About 60%, I would say, around there, of our radical equations are going to be square roots. However, we do have other types of roots. Okay? And to solve them, we have to keep in mind that since we have a variable underneath the radical, we're going to actually power what I call take a power of it. When we do that, we take the chance of introducing what we call an extraneous root. And an extraneous root is one that is false. In other words, it does not work. So, in the past, it's sometimes when you do equations, you have the choice to prove or to check the answers. In this type of equations, you do not have a choice. You need to check it because sometimes you do introduce what we call an extraneous root. So how do you do it? Okay? The directions will be solved. All right? It looks like something like this, the type of equation. Number one, the square root of x plus 2 plus 4 equals 7. Okay? All right. Here's the situation. We have a variable underneath the radical sign. Okay, so therefore, this is what we call a radical equation. All right. To solve it, we solve for the radical. So wherever the radical is, and if you have two radicals, you solve for one at a time. All right. So we're going to solve for the radical. So we're going to solve for this. All right. So in other words, we're going to take the square root of x plus 2, and we're going to move the 4 to the other side, so we're going to get the square root of x plus 2 equals 3. Okay? This is what, maybe a better word would be this. I'm sorry. Isolate the radical. Okay? I don't want to use the solve maybe there because the directions say solve. It might be misleading. So isolate the radical. Okay, once the radical is isolated by itself, then we power up. We power up. So if this is a square root, we square both sides. If it's a cubed root, we cube both sides. If it's the fourth root, we take the fourth power of both sides. Do you understand what I'm saying? Mm-hmm. So we power up. Okay, depending on what power, what square root, or what radical we have, we power up. When you take the square of this, you get what's underneath the radical. Does everybody understand it? This is the step, folks, that introduces that extraneous root, if there is one. Okay? And this is 9, and then we solve. Solve for x. Okay? And so we subtract 2 from both sides. We get x equals 7, and then we check. Now, you remember UPSI? When you were in 7th grade, understand, plan, solve, and check. This is IPSI. Okay? It's twin brother. Isolate, power up, solve, check. Okay? Alright, so what we want to do is we want to put 7 back in there. 7 plus 2 is what?
9.
What's the square root of 9?
3.
3 plus 4 is?
7.
It works. So this is your answer. Okay? Alright?
How do you know what kind of like if you power up or like multiply it by the little 3, or like how do you know what one to use?
If it's a square root, use 2. If this has a little 3 in it, that means a cubed root, and I'll show you a couple more of those. Okay? Yep. All right, let's try this one. Okay, how is this one different?
It has the radicals on both sides.
It has radicals on both sides, okay? So you see these steps right here? I'm gonna put a little arrow here because you can keep doing those until we run out of radicals, okay? Oops, I got my arrows in the wrong spot. Okay, why don't I do one and I'll show you and then I'll put my arrows in. Maybe it'll have more meaning to you, okay? This one, this radical is already isolated. Do you understand that?
Yeah.
Which one?
This one. I could isolate that one if I wanted to, but I think that it's better to isolate the more complicated one. This one is more complicated because it actually has a quantity underneath the radical sign, where this one does not, okay? So we're going to power up. Since it's a square root, we power up this way. However, you have to power up that as a quantity. This is what students don't exactly like. Okay, this one, everything comes out of the radical. Do you understand that? This one, however, you have to treat it like foil. Well, it's not very fun to deal with. Okay? All right, so I'm going to go x minus 12 equals, and I'm going to do this 4 minus 2 square root x minus 2 square root x plus the square root of x squared. Do you all see that? Lila,
Yeah.
are you good?
Yeah.
Okay. All right. So I got x minus 12 equals, and let's just clean this up. 4. These two are like. Do you understand that?
Mhm.
They're like. Minus 4 square root of x, because if you got two of them, negative 2 and a negative 2 is negative 4. And then this is plus, remember it was plus, because negative times negative. And when you take the square root of x, the square of x, quantity squared, you get x. Does everybody understand that? Okay. So what you, do you have a question?
No, I'm just trying to keep up.
Okay. We still got a radical. Okay? So we have to isolate the radical. Okay? So I got my arrows. Remember when I said my arrows were messed up? Now it should make more sense. I isolate the radical, I power up, but you'll notice that I created another radical, didn't I? So I have to isolate it, and I gotta keep doing this till I run out of radicals. Now it only is gonna happen twice. So, yes, ma'am.
So are we gonna have 4 minus x and move that to the other side?
Yes, I am. Yep, you ready?
Mhm.
Okay, so I'm gonna change this to plus and negative, and I'm gonna subtract, this is plus and negative, and I'm gonna subtract an x from both sides. Okay, and I'm gonna have a negative 12 minus 4 equals, minus 4, right? Equals a negative 4 square root of x. Is that true if I subtract both of them from both sides? What is x minus x?
0.
That's kind of nice, isn't it? But then I have a negative 16 equals a negative 4 square root of x. Are we good?
Yep.
Now I'm back here to isolate the power, all right? So I want to think about powering up. Except for, I have this negative 4 times that. Do you get that? Okay? That's not part of the radical, is it? Okay, two things can happen here. If this does not go into this, I would suggest squaring all of it and squaring this side. However, this goes into it evenly without a remainder, doesn't it? So I would divide both sides by negative 4. It does two things. It gets my radical all by itself, and look what it does. Makes that number more bearable. Now, I want to go back to this. Can you have a square root of a value equal a negative number?
No.
No. So we were this was a good thing that it became positive. Now we can get an answer. Folks, if you ever you isolate, listen very carefully. If you ever isolate a radical, okay, and it equals a negative, it's no solution. Right there and then, because you cannot take the square root of a number and get a negative number. It's not possible. Okay? I'll say that again. If you ever isolate it and the other side is negative, you isolate it completely. So there's not a number in front of it. You isolate it completely and you have a number on the other side that's negative, it's no solution. You can stop there. Okay? All right, well now we're right here. We need to power up again. Remember, we've done this twice. We're going to power up, we're going to square both sides. And I get x equals 16. Now I do have to check it, don't I? I think you're going to find something out here. Let's go back. You always check it in the original before you squared it. Okay, so and I can't do this one in my head, so I'm going to go ahead and do 16 minus 12 equals 2 minus the square root of 16. You ready? Watch what happens. 16 minus 12 is 4, so you have the square root of 4. On this side you have 2 minus what? 4? This is 2, and this is a negative 2. Do they equal each other?
No.
16 does not work. This is no solution.
All that.
All that to find out that there's no solution. But I will tell you something, Lila. No solution is the answer. Okay? I know you want to say, man, we did all that, but it is an answer. Okay? All right. Now, earlier, Lila said, what happens, how do you know when to use a different power up? Okay, there's one of these on the test, I remember it. This warning. Okay. 1/3 power is the same as the cubed root. Do you remember that? In other words, this could be written like this.
Is it that way for like 1/4? Or no?
Yes. Well, say like this one here. This could be x plus 2 to the 1/2 power. Okay? Do you see what I'm saying? So you can write it to a fraction power. That means the same as a cubed root or a square root. All right? Okay? All right. So these are the same. They're the same. I'm going to go ahead and just complete this like I would that. So I'm going to isolate it. I'm going to move the 4 over first. Okay? Lila, you okay?
Yeah.
Now what?
Divide everything by 2.
Divide everything by 2. Correct? And now, it's like the cubed root, so I would power up 3. So I would take this to the 3rd power, and this to the 3rd power. Now, when you take something to the 3rd power, when you take a power of power, what do you do with these? Power of power, what do we do with the exponents? We multiply. So what's 3 times 1/3?
1.
3,
1.
1.
How about 1? Okay? So what we get is 6 times 3 to the 1 power, which is 6x minus 3.
Okay.
And over here we get 2 times 2 times 2, which is 8. And now we just solve. I don't have any more radicals, so I go down my line of IPSI. I powered up, I'm going to solve, and I'm going to check it. So I'm going to move that 3 over. So I have 6x equals 11. And
No.
so divide by 6, I get x equals 11/6. Not a pretty answer, but let's see if it works. 2 times 6 times 11 over 6. Oops, I just put pi instead of 11. Must be getting close to pi day. God, I did it again. 11/6. It's really hard for me not to do that. All right, let's check it, see if we can come up with 0. These 6's cancel, you understand that, right? So 2 times 11 minus 8 to the 1/3 power minus 4. Does it equal 0? That's the question mark.
Wait, why did you put 8?
I have no idea.
11 minus 3 is 8. My brain was one step ahead, my hand was one step behind.
So 2 times 8 to the 1/3 minus 4 equals 0.
What does 8 to the 1/3 mean?
1/3
1/3
of
of
8.
8.
No,
8 to the third power.
it's the cubed root of 8.
Oh.
What's the
Two.
cubed root of 8?
2.
2. 2 times 2 times 2 is 8.
So this is 2, so we have 2 times 2 minus 4. Does 4 minus 4 equal 0? It does, doesn't it?
Yeah.
So this checks out. We put the old goose eggs around it, and it's a wiener.
So I think I missed this, but what'd you do with the 11?
11 minus 3
Okay.
is 8. Okay? Does that make sense? So if I had the 4th root, I would take it to a power of 4. Is that correct?
Yeah.
All right. Do we understand equations? Solving radical equations. All right. Okay? Now, we have inequalities. They are a little tougher. I do it a little bit differently than the book. So if you go back and look at the book, it's a little bit, it's different. You'll think it's completely different, but it's not. It's just simply a little different. It looks completely different. It's called a radical inequality. It's the same as a radical equation. We have a variable underneath the radical sign, except for it has an inequality sign instead of an equal sign.
Let's see.
Thank you. All right. Does that make sense to you?
Yeah.
What's that?
Yeah.
Okay. How about the rest of you? I just got a 1.
Yes.
What that?
I'm not really sure, man.
You're gonna wait and see what happens? All right. I don't blame you. All right, let me give you an example of what a radical inequality looks like, and how we solve it. Okay? A radical inequality requires a couple of steps because of that inequality sign. All right? An equation doesn't because it works fairly nice. But here's, what number am I on? 4? Okay, you see it? All right. The first thing is we have to make sure that this stays above 0, which we didn't have to do in the other. Okay, so whatever that is, we have to make sure that it is above 0. And that's mathematically how you write, keep it above 0. Greater than or equal to that. Do you agree? Okay, so now we just solve for x. Okay? So x has to be 2 or above. And it could equal to. Okay? So if our answer doesn't do that, we're gonna make our answer do that. Okay? We're gonna keep our answer. That's gonna be a boundary. And notice I do that off to the right because I'm gonna solve it here, right? And now, remember if we ever multiply or divide by a negative number, we must switch the inequality sign. Remember that? Okay, so we're gonna follow those rules, but we're gonna just go ahead and do what we did before. Remember, IPSI, isolate, power up, solve, check. All right? So we're gonna subtract 3 from both sides. And to that gets 5. Are we good with that? I've now isolated the radical, and so I'm gonna power up. And I get 5x minus 10 is less than or equal to 25. I'm gonna add 10 to both sides, so I get 5x is less than or equal to 35. Remember that you can add and subtract positive and negative numbers and we never switch the sign. Okay, it's when we multiply or divide by a negative that we switch the sign. Divide by 5, divide by 5, x is less than or equal to 7. Okay, so we know we have some boundaries set, okay? And this is how I do it. The book does it a little different. I create a number line, and I go from my lower boundary, which is 2, to my upper boundary. You can, it's always nice to put one extra on each other, just so you know, okay? Now folks, what I do is I create boundaries, what I call them boundaries, all right? So there's a boundary at 2, and it's solid, okay? How do I know it's solid? Because it's greater than or equal to, right? If it just says greater than, I dash this line, because it does not include that boundary. Same with the 7, okay? Now what happens is there are 3 areas that I have to check. 1, 2, 3. You see them? 1, 2, 3. Now, I'm going to show you how to, and I do it differently in the book. The book uses different notation, but I'm going to use interval notation. Remember interval notation? This area goes from a negative infinity, wish I would have left more room there, to 2, and it touches 2. Do you understand it? This area goes from 2, which it touches, to 7, and it touches both of them. You understand it? Lila?
Yeah.
Okay. Brian?
Yep.
Okay, this area starts at 7 and goes to infinity, but it can't touch that. You can't touch it. All right? Okay. Now what I'm going to do is I'm going to check a point from each area. Now it's not necessary to be accurate, it just needs to be, we just have to check whether the value is less than or equal to 8. So I'm going to put it back into this original. So the first area I'm going to check is this area. What point would be the best point in this area to check?
0.
0. Or 1. 1's nice too, but 0's really nice. Because if I put 0 in here, I get 0 minus 10, which is the square root of negative 10. Can you get the square root of negative 10? No. This area is out. He's gone. Okay? All right. Are we good? Let's go to the next area. What would you like to pick from that area? You have choices. You could, all these numbers in here, plus these guys in the
What
middle.
about 10?
You can't pick 10.
Or
10.
not 10, I mean 2.
I-
No, you can't pick 10.
Pick it from the area. How about 4? It's really easy, guys. You can pick 3 or 4 or 5 or 6. It's like you guys, okay, let's pick 4. Okay, so we have 3 plus the square root, 4 times 5 is 20, 20 minus 10 is less than or equal to 8. Okay, so can you tell me what's the square root of 10? Oh yeah, it does have one. And here's how we do it, okay? Here's how we do it. The square root of 10 is 3 point something. How do I know that?
Square root of 9 is 3.
Right, square root of 9 is 3, so it's just over 3. So what's 3 plus 3?
6.
Is that less than 8?
Yeah.
Yeah. So we're good to go here. This area works. Yay. Got one more area to check. I'm gonna go ahead and use 8. Is that all right?
Yeah.
Okay, but pick a point that's clearly in that area. So I have 3 plus the square root of 5 times 8, which is 40, minus 10 is less than or equal to 8. I have 3 plus the square root of 30 is less than or equal to 8. Well, the square root of 30 is about 5 point something, isn't it? Well, it's over 5, right? Because 5 times 5 is 25. What's 3 plus 5 point something?
8.
Greater than 8, isn't it? This area does not work. My answer is from 2 to 7. How do you like those apples?
Here's some
They're
round apples.
sour. They're very
They're
bright.
sour?
Yeah.
Alright. Well, let's do one from the assignment, shall we? So 48 through 52. I have a copy. Yes, ma'am.
Do you have time for a question or not?
Yeah.
If you do.
Can we pause that?
Well, stop it.